All right. So I decided to shoot, kind of record this video because I think that this paper is a little bit confusing. It is a bit confusing because of the wordings. What is a proxy? What's not a proxy? Like previous versions of the paper, they were they have been misinterpreted, and I think that with the presentation, I'm going to be able to clarify it a little bit better. The other thing is that I thought that this was going to take like 20 minutes, but by the number of slides that I have here, I think it's going to take more than that, and which means that I'm going to cut this video into 3 or 4 parts. We're going to have this one, and then the next one is going to start at the main point of the paper, the point that actually explains the main intuition of the paper, and then there will be another one or another two videos, depending on how long it takes to do that part. Okay. All right. So let me start with the presentation. Then the title of the paper here, the dynamics of changing correlations, identification of stock returns, and the first thing is what the paper is about, and the question in the paper, the the question that the paper wants to answer is what is the explanation of the size and the value premiums? And this is kind of an old-fashioned question because it's not exactly what have been what people have been doing lately, which is more like data mining and data-driven, like machine learning, etc. Uh, but I want to talk about this because it's as I will show later, it's an important it has important implications. So questions that are related to this, to the reason, to the explanation of the size of the value premium, they are, for example, for like more generally, they are like why exactly do we make money from these stocks, or we expect to make money from these stocks? Uh, when and if we change from small to big, from value to growth, or big to value, or whatever, whatever change you want to make in the investment, what are the risks that are related to these stocks? Why exactly do we scale by price by book equity and not something else? Like, for example, it could be dividends or earnings or something else. And the other point is that the paper obviously it was maybe not obviously, but the paper was not meant to explain why the value premium doesn't work anymore or doesn't seem to work based on book to market. But in this sense, the paper has aged well. The paper actually starts in 2012. Like the first seed of the paper is actually in 2012. It's in another paper about the size premium. But nevertheless, the paper still helps us understanding why exactly that what's wrong, let's say, with value in the past 20 years. Uh, from a more academic perspective, what the paper can be seen as discussing also is if the Fama and French type of models they are valid for risk adjustment, and if they are not valid for risk adjustment, if they are at least valid to describe expected returns. And then obviously, apart from this, it's all the theoretical. That's the main point of the paper: the theoretical explanations for the size of the value premiums, right? So those are more like secondary questions. One point that I think it's important, especially because this version of the paper got so much different from the first one and so much more formal than the first one, then it might look like just another theory paper that's completely unrelated to any use. And that's not the case. So it's an old-fashioned paper, but that's not the case that it's just another theory paper without use. And the reason I can tell you that it's not, and then I need to cite myself because I'm the only one that knows about this so far, is that, for example, this is actually the paper that originated everything in 2012, the price of risk fluctuations and the size premium. Basically, it tells you exactly the 10% of the years in which you have a size premium and 90% you don't. These other papers about solving the momentum puzzle and forecasting momentum returns. This other one is about raising, apart from other things, raising the value the Sharpe ratio of the value premium, the new value premium. like by 50% just by understanding that book equity is just a proxy for expected cash flows. And then I have other papers like macrofinance, factor time, and carry trade time, and they all draw on the same idea of this paper. So it's not really just another theory paper. All right. So now that we have this out of the way, what exactly do we learn in this paper? Well, the things that I learned in this paper is that first that the present value identity explains both premiums, the size and the value premiums. And this is in contrast with most, probably all theories that I know actually. Most other theories or all other theories, they cannot explain the size of the value premium. And I'm going to show you why and under which conditions they can't. We also learned that for a small subset of the firms, book equity is a good proxy for expected cash flows, and that's all. There's no intrinsic relation. There are no missing factors which size and book to market proxy for. There are no stable economic relations between risk and size or risk and book to market. These are in fact inconsistent with the present value identity. So you kind of need to decide if you believe the present value identity or if you believe one of these theories that link some risk directly to these characteristics or indirectly, but intrinsically. It's also largely inconsistent with empirical evidence. Then for the empirical evidence, I'm going to tell more about what assumptions I need to make to actually make this testable and rejectable. And the final point is that regressions that rely on size-related factor portfolio, they are not unconditional models of returns, or they should not be unconditional model of returns exactly because the factors don't have conditional risks. The conditional risks change. All right. So how is the presentation structured? Well, I'm going to start with the solution straight away. So that's the answer for the puzzles. And I'm going to derive it first in a static setting. And basically the conclusion that I get on the static setting, if I stop at the static setting, is that I cannot tell anything. I cannot tell which theory is wrong and compare this with any other theory. Because they are all equivalent in a static setting. So what I do is I take this intertemporal step, and then I look at what exactly happens intertemporally, and that's precisely where the contribution of the paper is. It's described this type of result, and then from that I get the rejectable implications from the theory that I propose in the paper, which is basically the present value identity with a few extra assumptions to make everything testable. Now, after that, I go to what I call causation theories, which is a very large group of theories that basically, at least as far as I know, includes all other theories of the size and the value premium. They're all equivalent empirically, so they all generate the same rejectable implications. In a static version, as I said, we cannot tell one from another, like the theory that I propose and these other ones. But if you go to if you consider an intertemporal setting, then you can tell one from the other using the implications that I have. Now, again, I need to make some assumptions to actually get the theoretical the empirical implications, which I will also explain. Then next, after that, I just go and show you the empirical evidence, data and variables, results, and conclude. All right, so let me start already with the solution of the two puzzles, and let's consider the static setting. And what's nice about the paper is that the answer is as simple and as fundamental as the present value identity. There's not much more than that. It's almost like Burke in 95. That's the solution of the size premium in 95. It's not exactly like Burke because for Burke, prices are also, and it could be also related to mispricing. And I only consider that price is related to risk. I don't consider mispricing. Of course, that you could come up with a story involving mispricing instead of risk because they end up generating the same results empirically. But the framework that I use is a risk framework. But it's almost the same as Burke because basically what Burke said, and I'm actually a bit surprised that it's not so used. But what he basically noticed is that, well, if you take the price and you take an expected cash flows, let's say one period ahead, you discount it by the risk-free by the by the risk premium. I'm assuming here that the risk-free rate is zero. Then in logs, I think it becomes clearer. You have the price, is just expected cash flow minus whatever you expect to be the return, right? So that's the risk premium, and then you have this negative relation here between price and risk. Risk is sigma is risk. All these bold, I cannot really see that it's bold, but it's bold. All these bold variables here, they are vectors. So what I mean is that there are so each position in the vector, each element in this vector is exposure to one shock, one economic shock. So there are multiple of them. And lambda is the price of each of these risks, and then the transposition here just multiply one by the other and adds all of them. So this is the risk premium, and you have this relation here between price and risk from the present value identity, right? There's no relation, no reason for price to be related to cash flows. Of course, one referee said, "Well, but maybe there is." Of course, there is. There is a possibility that they are correlated. If they are, then we are on the causation theory formulation, and I will show why this cannot be true. So, but basically what we have is this. We have the present value, and we have the price equals to expected cash flows minus the risk premium. That's for the size premium, for the market price. Sorry, for the market equity. Now, this is also going to be true, like this relation is going to be true if you scale price by anything, absolutely anything. You could even scale this by the CEO's number plate or the national insurance number, whatever you want to scale price with. You are still going to end up with something that is correlated with risk. And the reason for this is because, for example, let's say that you scale by book equity, which is what I'm going to discuss. Well, then you get the book to market. Let's call this the book to market, because the way it's called, and then you're going to end up with whatever is the variable that you used. In this case, it's book equity. It could be CEO's number plate here, minus expected cash flow, and then you have now because you subtract it, now you have a positive relation. So book to market is positively related to risk, right? The same way that price is negatively related to risk, book to market is positively correlated to risk. Now, the big question is why exactly book equity? How come did we end up with book equity? According to this theory, or according to the theory that I propose, it was not exactly by chance, but it was more or less like a data mining that I'm calling evolution pressure to find high correlation with expected cash flows. Because if you find something that's highly correlated with expected cash flows, then you're going to find something you're going to find that whatever variable you have here is going to be highly correlated with risk premiums. And this is exactly the objective of everyone that was data mining variables like accounting variables, price variables, etc. That was their objective, right? So there's kind of a Darwinistic evolution pressure to find exactly something that is correlated with cash flows. And that's the answer that I give for, and it's also obviously the answer that Burke has, just not with this kind of uh, story of evolution pressure, etc. But it's also the same explanation that Burke has for the book to market. It's a correlation between cash flows, expected cash flows, and book equity. And because it is correlated, then you end up with something that somehow controls for differences in cash flows. Because, for example, if you look at the price is correlated with risk, but there's this expected cash flow which kind of messes up with the ranking, right? So it's not a very good ranking if you rank by price. You get a better ranking empirically because of this evolution here. You get a better ranking if you actually rank it by book to market. Then you have a higher premium and so on. And what's important, and it's nice in this, not exactly in this paper, but in my other papers, that this was a time when the U.S. was mostly industrial. So book to market, book equity was tended to be very correlated with expected cash flow. That's not true anymore. It's not true that Amazon needs a lot of book equity to generate cash flows, or Apple or Facebook. These firms don't need a lot of book equity to generate cash flows. They generate it in a different way, and that's the type of thing that you need to consider if you want to model expected cash flows now. And that's also one of the reasons why value doesn't work anymore, because you have this transition in this change in the economy. So far, maybe we are going to get to a point where we need again, right? But that's the idea. Um, the other thing is that although it's very nice until here, right? It's all nice, and then I have a book equity, and that's very clean and very directly arising from the present value identity. There is also some dark matter, like in the sense of untestable assumptions that I need to make to actually generate some of the result that we see in the data. And the dark matter in this explanation, the theory that I propose, this is basically the theory already, kind of. So the dark matter in this theory is going to be an assumption about how exactly book equity, book equity and cash flows, expected cash flows are correlated. So what I'm saying is that there's a very high correlation. One, it's a perfect correlation in only 5% of the firms, and then the vast majority has a very low correlation. If you do this, if you make this type of assumption, what you have is something like a cross-sectional regression or square of 2% if you could regress one or the other, so it doesn't seem too far off. And the main reason why I have this, I'm going to explain later, is because I want to explain why the size premium is bigger than the value premium in high price of risk states. So if we have this type of uh, dark matter, so if this type of dark matter really is correct, then we are going to have what I'm saying. I don't think also it's too far off, but it's still like I can give you lots of reason why I believe that this is actually not off, that it's actually true, but it's still not testable because it depends on expected cash flows, which is essentially untestable, like no matter what, because it's not dividends. This is not nothing that you can actually measure. Right. Okay, so this is the dark matter in the explanation. Just to be clear that it's not all just derived from the present value identity. Now, what is the problem with this explanation? The problem is that this explanation is scientifically indistinguishable from all the others, uh, in the sense that if you look at what exactly this explanation gives, it gives you this type of relation here. It tells that the risk of the firm is correlated with a firm characteristic here, kappa, which can be size or book to market or market cap and book to market. And because you have this, you're going to have that if you construct a portfolio, like you have all the high book to market in one side, all the low book to market in the other side, what this representation here implies is that the risk of this portfolio, of this HML portfolio, for example, is going to be this BT, which is it's a vector that relates the characteristic to each of the elements here in this also vector. And this is going to determine the risk of the portfolio, right? So depending on which of these elements is related to let's say book to market, you're going to have some exposure to that particular shock. But the problem, and that's the main problem, is that this is the only testable implication that you get from this type of model. You get one for book to market, you get another for size. You don't have anything about which one is larger than the other because you don't really know whether book equity is a good proxy for expected. I mean, there's nothing in the theory that says that book equity is a good proxy for expected cash flows. Nothing clearly states that book equity is a good proxy for expected cash flows. Nothing that says, for example, you might use the CEO's number plate and then you would get a completely different result. So you don't really know um, which premium is going to be larger than the other. And most importantly, when I talk about the causation theories, which is all the other theories, at least the ones that I know about the size of the value premium, they generate exactly the same implication. So I cannot really tell one theory from the other based on this static setting. That's the main conclusion here. Now, this is a problem in a static setting, but fortunately, this is not what happens in an intertemporal setting. In the temporal setting, they are not going to be equivalent, and that's the main point that I want to show.